Okay, as I mentioned, we're going to continue lecturing here at chapter 16 because frankly, we got nothing else to do. Why not, I suppose. All right, we're going to lecture here for a bit, and then obviously we will wrap it up for the week, and we'll talk about next week. And I think we have an exam coming up, I think, all that good stuff. All right, so we've been talking obviously about pH here at the end there and calculating pH again. As we just sort of saw, the pH is equal to minus the log of the H plus concentration. Once again, as we saw in that last example, and we'll talk about it here in just a second one more time, you could actually calculate something known as the POH, which is minus the log of the OH minus concentration. They are kind of similar in terms of how they're calculated. And really, the name tells you what you need. pH means you need the H plus concentration. POH obviously means that you do need the OH minus concentration. And like I said, there's a really nice relationship between those two, that the pH plus the POH equals 14. So although I did originally the previous problem using KW to get to the H plus concentration and then got the pH, this also allows you an alternative approach to doing that, where you can take the POH and basically just take 14 minus it to get yourself to the pH equation formula at that point. As you saw, though, it doesn't really matter which way you choose. They both should give you pretty much the same answer. Maybe a slight difference if you rounded a lot with the concentration that you calculated, but should be pretty close to each other. So as we talked about, the pH is really based off of the log scale of 10. And what that means is pretty much for every sort of change in pH that occurs by 1 unit, you're basically changing the concentration of H plus by 1 factor of power of 10. So again, as I mentioned, if you have any sort of H plus concentration that's 1 times 10 to whatever it may be, that will give you your pH. So 1 times 10 to the minus 3 gives you a pH of 3, to the minus 4, 4, and obviously to the minus 5, 5. The relationship between pH and H plus and all that good stuff is this: as the H plus concentration increases, the pH actually decreases. It becomes more acidic. And the relationship with OH minus is the opposite. The OH minus concentration would go down. So basically in that solution, you have a lot more free floating H plus, which is going to make the solution more acidic and a lower pH. And obviously you have a smaller amount of OH minus floating in there. The opposite would be true, obviously, if the H plus concentration went down, I'm sorry. The pH would then go up. And the reason the pH would go up is really because your OH minus concentration would go up in that case as well. So in that opposite case there, as the H plus concentration goes down, the OH minus concentration rises. You basically have a lot more base in that solution, and the pH would reflect that, and you would end up with a higher pH at that point. So there are different ways to measure pH, and we did some of those the other day there, except we didn't use a pH meter. A pH meter is this guy on the left, and it's sort of an electrode, and it really measures the H plus concentration that's in the solution. Really how it measures is like by using voltage, basically. And you basically use some standards and go, this is like a pH of 7, and you calibrate your pH meter, and it goes, okay, that voltage is a pH of 7, and you go, this is the pH of 4, and it figures the voltage, does a little calibration curve, and it's able to give you the pH reading directly. Nice thing about pH meters is you basically just stick it in there and it gives you a number, so it's really well. This is sort of what you guys did on the other side, which is use some pH paper. Again, kind of like you clean the pool and stuff, those kind of papers, you put it in there, you try to match up the color, and obviously try to find the pH, not as maybe accurate as well. We also use Litmus paper, which really doesn't measure pH, but it does tell you whether or not a solution is acidic or basic. And as we talked about, pretty much if your Litmus paper turns red or stays red, it's acidic. And if it turns blue or stays blue, it's basic. in that case. And again, it doesn't tell you the pH, obviously, but it does tell you if it's acidic or basic. Here is our pH scale. And as I mentioned before, above 7, there's basic. So we see things like sodium hydroxide, which is a strong base, ammonia, which is a weak base. We also see some obviously acids down here at the lower pHs, things like vinegar, which is like acetic acid, HCl. Pure water, which is 7. And again, as I talked about earlier today, if you don't really have pure water, but water is maybe not filtered really well, or that has been sitting out a while, you probably find the pH around there because of that sort of collection of CO2 and the carbonic acid. Because what happens, again, as I mentioned, is it sort of makes carbonic acid, increases the H plus concentration. So H plus goes up, pH goes down. So again, it goes away from 7 because of that. So we kind of jumped the gun on this one, but again, just a reminder here that the POH is minus the log of the POH minus the log of the OH minus concentration. The pH scale runs, as I said, opposite of the pH scale. So the POH scale is opposite of that. So, you know, you should always look at the pH when you're trying to determine if something is acidic, basic, or neutral. So on the pH scale, that again is 0 to 7 to 14. And that's what most people have in their head, is the pH scale. Now, if you have a low pH, you have a high POH, and vice versa. If you have a high pH, you have a low POH. They run opposites of each other, which is why they add up to 14. They're opposite ends of each other, basically half of the scale. So when you add it up to 14, the pH and the POH, that's their entire scale. As I mentioned earlier, sometimes people will give the answer of it's acidic and basic. And the reason for that is simply they will calculate the pH and go, it's above 7, so it's basic, but then they will calculate the POH and go, it's below 7, so it's acidic, and they end up giving the multiple answers for that. So always look at the pH value, because that's probably what you have in your head in terms of the scale. And again, should only be one answer on that question. So some useful stuff that we've seen, which is, again, KW is H plus, OH minus. 1 times 10 to the minus 14. We have our pH calculation, our POH calculation, obviously our relationship there. I'll draw a little bit higher because this room you can't really see. pH plus POH is equal to 14 up there. So those are some really important things. We'll add to this list a couple of other calculations that we do as well. If you actually are given the pH, you can get from that directly the H plus concentration. So if you are directly given the pH or you have the pH, you could actually get the H plus concentration by taking the inverse log of the minus pH. The inverse log on your calculator is usually on most people's the top left button, which is like your shift or second button, and your log button. So usually you have a button on your calculator that says log, and above it, it says like 10 to the X or 10 to the caret, something like that. Usually 10 to the X, I think. That's how a lot of people do scientific notation incorrectly. This is actually what you should use that button for. So you want to hit the second button, the shift button, top left corner usually. And usually what it will actually put up on your screen is like a 10 and a caret. Is kind of like what it usually will pop up on the display. And then you want to make sure you do the negative pH. So that is how you get to there. Also, if you have the POH, you could do a similar calculation, and you could get the OH minus concentration by taking the inverse log of the minus POH. Once again, usually will pop up like a 10 and a caret. And POH is what you want to hit on your calculator. So those are 2 other things that you can sort of add to the list of different ways we could solve these problems. It does give you a lot of different ways to solve it. Again, if you have the pH, you can get the POH directly from it. You could get the H plus from it without even needing to use KW. You could also still use KW in situations as well. So you can intermingle all these sort of ways to solve for whatever you're looking for. So it does give you some options. They all should end up giving you the same answer. Again, you might be slightly off if you do some extreme rounding, but you should be pretty close no matter sort of which path you choose there. Any questions on that there? All right. So let's try some here. Calculate the pH and POH for each of these. While we're at it, let's just let's do for this first one, the pH, the POH. Let's also do the OH minus concentration. And is it acidic, basic, or neutral? And for the second one, let's do the pH, the POH, the H plus concentration, and is it acidic, basic, or neutral? All right, let's take a look at this first one here. So we have an H plus concentration of 3.6 times 10 to the minus 9. So really, since we're looking to solve for everything, we have two options. We could go into KW to get the OH minus concentration. We obviously could go directly into the pH equation. So that is what I'm going to do, is go directly into the pH minus the log of 3.6 times 10 to the minus 9. That is going to give me a pH here of, call it 8.44. Now that I have the pH, I can get the POH by simply just taking 14 minus it. That would give me 14 minus 8.44, which would give me a POH of 556. Now, because I also have the pH here, I'll just do the new sort of calculation, if you will. I'm going to take this here and use it to find the H plus concentration, which would be the inverse log of the minus pH. That again, usually we'll put a 10 and a caret minus 8.44. Once again, on your calculator, usually like the second or shift button, the log button, and negative and 8.44. And if we did that there, I can find it on my calculator. There it is. Negative 8.44. Gives me something like 3.6 times 10 to the minus 9 molar. Again, if you don't have your calculator in scientific notation, you might have a bunch of zeros and a 3 at the end, and it might have died out. That again should be the exact same number you get if you did 1 times 10 to the minus 14 divided by 3.6 to the minus 9. Should get you that number there. Hopefully. Let me try that again. There we go. 1 to the minus 14 divided by 3.6 to the minus 9. What's that? That does not look right there. I did the wrong one. I'm sorry. I did the exact one that was there, huh? I'm like, wait a sec, that don't look right. Well, the good news is I got the answer that was there. That was good. Let's try that right number there. I actually want the OH minus concentration. That would be good. I'm like, that doesn't look right. Try that, the OH minus concentration. So we're going to take the POH, which we will extend my arrow to the right number, which should be right there. That is going to be 5.56. I'm new to this chemistry thing. Leave me alone. All right. All right. I'm thinking about taking some chemistry courses over the summer. I'll be okay. So to that, minus 5.56. How about a 2.8? How's that? Times 10 to the minus 6. That sounds better. There you go. And that should actually be the number that you get if you do 1 to the minus 14 divided by 3.6 to the minus 9. There we go. All right. Question? Yes. Yeah, so let's talk about that now that I do have, I think, the right numbers up here, and sort of what everything should look like. So first off, we started with a concentration here that had 2 significant figures, which means when we calculated the pH, we do need to go to decimal places, 2 decimal places. So that's good. When we subtracted the 14, we should maintain those 2 decimal places, which means that when we go from the POH back to the concentration, we're starting with 2 decimal places, which should translate to 2 significant figures. So it works kind of both ways, depending on which way you're going. If you're going from concentration to pH or POH, you should go significant figures to decimal places. Obviously, if you're using the pH or the POH to get the concentration, you should go by decimal places back to significant figures. So kept all those numbers there. So to answer your question, 2.78 technically would be incorrect in terms of significant figures, because our POH value had 2 decimal places. So you should end up with 2 significant figures. Yeah. Yeah, so you would probably still, even when you use KW, sometimes most people will use 1.0 times 10 to the minus 14. Some people will just use 1 times 10 to the minus 14. So probably when you're using KW, you want to just reference the other concentration that you're putting in there. So 3.6 would have the 2 significant figures. So even if you did 1.0 or 1 or whatever, you probably wouldn't do the sig figs based off of the concentration that you're putting in there, the H plus or the OH minus, and keep it about the same. It is 2. So when it's in scientific notation, any number before the times 10 part is significant. It would be. No, so you would have 2 significant figures. So 2.8 would be 2 significant figures, right? Right. So if you were just doing KW, it would be sig figs. So you just keep it the same sig figs. Yeah. Other questions? Okay. Last thing here was, is it acidic, basic, or neutral? This one is. It is basic, based off of the pH here, above 7. Any questions on any of those calculations on that one? Let's take a look at the next one. So same thing here. I have the OH minus given to me, so I'm not going to try to screw this up. I'm going to go with POH first, and I'm going to do minus the log of 9.2 times 10 to the minus 2. That is going to give me a POH of something with some numbers. Looks like a 1036, perhaps, yeah? Or 104. I'm going to learn how to read a calculator soon as well. Let's try this again. 9.2 minus 2. There we go. 1.04 will be our POH. Once again, 2 sig figs, 2 decimal places. That brings us to a pH in this case of 14 minus that, which would be 1.04. So we're going to minus 14, going to give us a 1296 on the pH. Now I'm going to pick the right one and use my pH here to get to the H plus concentration. Once again, I'm going to do the inverse log of the minus pH, 10 and a caret there of 12.96. And if I do that, looks like 1.1 times 10 to the minus 13 molar would be my H plus concentration. And this solution here should be basic as well. pH is above 7. H plus concentration is less than the OH minus concentration. Any question? Yeah. Yeah, so if you're going to do this one, I would say on most calculators, you do need to hit the button in the top left corner, which is usually a second or shift button. You then need to hit the log button, which should have a 10 to the X above it. And then you need to hit the negative button. And then you need to just put the number in. So it'll be 12.96 in this case. Yeah. There are some calculators, and I have one that actually has a dedicated button That is like, I believe, I think it's like 10 to the X and like an E on the same button. So that one you might have to kind of go through to do that without hitting the shift if you have that type of calculator. But most of them you gotta go shift or log, and shifts or second and then the log button to do it. Other questions on that? Okay. All right, so let us do not what's asked here just to make sure. Let us do the POH. Let's do the H plus and OH minus. And once again, is it acidic, basic, or neutral? So you'll be professionals at this by the time we're done. The pH. So for me, I'm just going to get the POH by subtracting the 14. That gives me a POH here of 8.33. Now, once again, I do have the pH and the POH, so we will do the H plus concentration equals our inverse log of the minus pH. So that's going to be a 10 and a caret and a 567. That will give me, not that, that will give me roughly 2.1 times 10 to the 1, 2, 3, 4, 5, 6 times 10 to the minus 6 molar. Now, again, at this point, I could use the POH and do the same calculation. I could also still use KW. So if I wanted to, I could just roll back to the KW, which is 10 times 1 times 10 to the minus 14 divided by my 2.1 times 10 to the minus 6. And if I do that, that gets me 4.7 times 10 to the minus 9 molar as well. So again, you could do it either way. You could again done the POH. Yes. Why is it? Say again. So the pH value has, when we look at the pH value for going sort of from here back to here, we would look at the number of decimal places, which is 2, which would give us 2 significant figures in the concentration. So it's decimal places to constant significant figures going from like pH or POH to concentration. If you're going from concentration to pH, then it's significant figures to decimal places that way. Yeah. Yeah. So it's not sig figs, it's sig figs. Yeah. Other questions on that? Yeah. Yeah, you should hopefully get the same number, I hope. It might be just the rounding because mine actually dead ended at 0 at 4, and then I put in scientific notation and I got 4.7. So it might just be the way your calculator rounds, maybe that based on it. Because when I do it, when my calculator is not in scientific notation. Yeah. Yeah, and mine has like 9, mine has the zeros and a 4. So it just might be slightly where the difference in the rounding. Since I use KW and you did the inverse log, when we do it that way and see what we get here. Minus 8.33. Yeah, I see mine still does that rounding. So I think it's just a slight way the calculators round and stuff like that, depending on mine, because mine was 4.7 or so. So mine gave me the 4.7, but yours might have just rounded it to 5 and then put it into scientific notation after it rounded it. Yeah. Other questions? Lastly here, though, this would then obviously be acidic, right? Based on the pH value here of 5.67. Any questions on any of those calculations there? All right, so we'll just do what this one asks. What is the pH? What is the H plus of a guy that has 3.14 for his pH value? So we'll just do H plus on this one. On this one here, we're going to use our H plus is equal to the inverse log of the minus pH. So punching that in, hopefully correctly here, will get you looks like 7.2 times 10 to the something. 1, 2, 3, 4 minus 4 looks like. And once again, 2 decimal places, 2 significant figures in that case. Yeah. Any questions on that one there? All right. One more. What is the OH minus concentration here if you have the POH of 5.67? Okay, so we got the POH. So once again, we can get directly from that measurement the OH minus concentration. Nice thing is they're all kind of the same calculations, just put the right numbers in there. We will then do our inverse log of the negative 5.67, and looks like we got a 2.1 times 10 minus 6, I think. And again, 2 decimal places, 2 significant figures going there. Any questions on these calculations? pH, POH, H plus, OH minus. All right, I think we will stop there for the torture for today.